So in fact, the future is the key word of our next speaker. Amy Webb is the founder and CEO of Future Today Institute and also a professor of strategic foresight at NYU Stern School of Business. Amy Webb, welcome to this online conference. This is a pleasure to have you with us, and thanks for joining us for quite an early time for you, since you're joining us from the East Coast of the US, so it should be something close to, 8 a.m. in the morning. In preparation of this session, I never asked you the question, but is futurist written on your business card?
Actually, CEO is written on my business card,
so
but I do get a lot of questions.
So which one do you prefer? That's maybe.
I prefer planner because my job is not about making predictions; it's about being prepared.
Great. Sharp. Thanks for. I think it's a perfect introduction to your session. So you're actually going to give us a keynote speech for 30 minutes. And we're going to have 10 minutes of question and answer right after. So I guess you should be triggered quite a lot by what Amy will share with you. So don't hesitate to really go into the Slido window, share your question, and I'll be happy to share them with Amy after a keynote speech. So Amy, what's the future look like?
What does the future look like in 30 minutes or less? Hello, everybody. Good morning from me to you. Good afternoon. It sounds like so far you've heard about some of the tremendous attract projects and really impressive research that's being done, not to mention some incredible students. So what I'd like to do is talk to you about the future, but I'd actually like to link the research and the projects and all of the innovations that you've been hearing about to some external emerging signals and trends, some of my research. And we're going to link those things together. So I'm going to spend about a half hour talking about the future. And I think what the future looks like is synthetic. So 3 very quick things about me. I'm a quantitative futurist. I guess on my business card, it technically says CEO because I am the Chief Executive Officer of the Future Today Institute. We are a data-driven, technology-led global futures organization. And we are management consultants to Fortune 100 companies, government agencies, investors, and banks, and others around the world. Most of my work has to do with tracking data, building models, and trying to figure out what the next order impacts look like. I teach strategic foresight at the NYU Stern School of Business, which means I'm always thinking about the kinds of research that you're hearing about, really advanced science and technology, and thinking through what the ecosystem might look like and what future regulatory frameworks might look like. Lastly, all of our work is open source. So at the very end, I'm going to give you a folder that has our methodology, some frameworks, some research, and other things to help you continue thinking through the future. So I think we're going to look back on this moment in time, on the 2020s, as an era of the coronavirus, obviously. But I also think we're going to look at this decade as the decade that brought us synthetic technology and science. So synthetic media. You can think of sort of AI characters whose storylines we can follow on social media, and human-like virtual assistants who make appointments and screen our calls. Of course, this also tells us something about the future of misinformation and confusion in the marketplace of ideas. This is also going to be the decade that brings us a different type of synthetic content. It'll bring us designer molecules in a range of host cells on demand and at scale, which will lead to transformational improvements in vaccine production, tissue production, medical treatments, and the like. In the next decade, scientists will start to build entire human chromosomes, and they'll be designing programmable proteins, living technology. Every company, every industry, every one of us will be impacted as our synthetic decade brings new business opportunities and strategic risks. So that's what I'm going to talk to you about for the next 25 minutes or so. I'm going to talk to you about the intersection of things that don't seem related, synthetic media, but also synthetic biology, And I'm going to offer some perspective on attract projects that you're probably already aware of, and how a future value network ties all of this together for government, for investors, and for researchers. All right, so by now, we're all familiar with digital assistants. Obviously, we know that Siri and Alexa aren't real people. They are synthesized for us to interact with. This is an example of synthetic media. So synthetic media is created using artificial intelligence. Algorithms use an initial set of data, an initial corpus to learn. So this might be people's faces, or voices, or photos, objects, motions, videos, text, things like that. And the end result is realistic looking and realistic sounding artificial or synthetic digital content. So examples of this include voice clones, voice skins. Gucci, believe it or not, the fashion house, just started selling a $10,000 totally synthetic dress that only exists online that you can buy. Not that you should. So there's lots of different examples of synthetic content. And sometimes, yes, this results in a deep fake for malicious purposes. On the other hand, we can also use the same technology to improve our productivity. You could synthesize your own voice and you could modulate it, or you could train a bot to answer questions for you. You can synthesize infinite versions of your face in real time. And so all of that's really interesting. However, it also makes it much more difficult to tell the difference between what's real and what's been tweaked. So when we talk about synthetic media, there are many different modalities. The easiest one to think about is your face, right? So this is me, and this is me with an algorithm applied to make me look what the algorithm thinks is more feminine. And I could use that same system to make me look more masculine. This is not, super high tech tools and software that required a render farm. I actually did all of this using an application on my mobile phone. So that's face. What about our voices? Because our voices are a key way that we communicate. So there are lots of different companies working on synthesizing voice. Google has obviously been one of those companies, in addition to Amazon and Apple. But one of the interesting things that Google is working on is not just synthesizing any voice, but literally synthesizing your voice and enabling you to talk with your voice in any other language. In fact, there are some off-the-shelf tools like this one that allows you to edit voices in and out. So if you type a bunch of text, you can automatically have that text synthesized into a voice that sounds just like you. And this makes it easier if you're hosting a podcast, for example, and you've said something slightly incorrect, or let's say your guest started coughing or something in the middle. You could simply take that out, type in what you wanted the person to say or what you meant to say, edit it back in, and really nobody would know the difference. All right, so there are other forms of synthetic media as well. And so in addition to your face and your voice, you can use synthetic media for narratives and for description. So this is some very compelling new research that allows you to type in, so say something or use text, and have that text rendered as a face. And this is what we call text-to-face generation. Now, what's interesting about this is at some point, all of us have been in a situation where we see somebody, but we can't remember their name, and we can't remember where we know them from. Imagine being able to sort of speak into a digital assistant and say, well, this person's got curly hair, they wear glasses, they're about, yay high. Who is this person, right? And then have a face shown on the other side. So this is very interesting, except when you look at how the system was built. So this is one of the examples in the paper. And as you can see, the way that they've described the text that they're using is this. The chubby old woman has gray hair with a smile. Now, obviously, age and the way that we see other people is totally dependent on your own worldview. But I'm guessing a lot of those women, if not all of them, are in their mid-40s, which is how old I am. And I would not call myself old. I would also not say that any of these women are chubby. So one of the problems underpinning some of this technology is that the data that we are using, the training data, to help some of these systems learn, are riddled with sort of strange biases. So if we combine faces and voices and gesture and some of these other things, that takes us to truly synthesized people. So this is an example of a digital human who doesn't exist in the real world. Reuters created a prototype of a sports announcer. So another way to think of him is that he is a fully programmable digital human who for right now is capable of generating his own content. So hear me out here. So this is a human composite host. He sounds and looks just like a real person reading the news. In fact, if you look on his lapel, he's wearing a little microphone just like me. And he's not real. An algorithm created a script out of structured data and used natural language generation, natural language processing, computer vision, a host of other things, right? And then another AI system generated him using an evolutionary algorithm. And then a system, not a person, cut together the footage, including a video highlight of that football game that you see, and created a newscast, all done without a human, a real human in the loop. These are synthetic people. So this is kind of an interesting beginning to what you're going to see a lot of over the next 10 years. This technology that in sort of disparate pieces has been kind of on the fringes is approaching the mainstream. This is a company that allows you to create your own AI video. So I can have a host, I can give the host a script, and ask the host to sort of say anything that I want. And this is already available to consumers to just play around with. Aletheia AI takes another interesting business approach. So they've developed synthetic characters that you can license and buy and use however you want. So if you're familiar with like iStock Photo or Getty Images, websites where you can buy photos, stock photos, this is kind of the same thing, except you can buy stock characters, synthetic people. And obviously, these are kind of silly looking. The third character in is a mashup of Donald Trump and Joe Exotic, for any of you who have watched Tiger King. But in other cases, these aren't meant to be silly. They're meant to be real. So this is a synthetic character that you can buy and you can program and have this synthetic character interact with real humans online. All right, so we're talking about synthetic voices, faces, narratives, and people. And I think it's useful now to think through all of that plus core infrastructure of society. So when we think about our modern core level infrastructure, of course, we're talking about things like bridges and roads, and the technology that exists at CERN. We're, in regular society, core level infrastructure includes things like a DNS backbone, network systems, network architecture. But there are other core level infrastructures that power our lives. For example, health technologies. If you think about medical schools and electronic health records, data management systems, diagnostics, these are also the core level infrastructure that powers life. This is really important because we have a lot of this core level health and medical and technology infrastructure in our homes and in our offices. Increasingly, all around the world, there are lots of connected devices inside of our homes, inside of our offices, and they do a variety of different things for us. That ranges from automatically turning on and off the lights to little Bluetooth speakers that you can speak to, right? And even remote controls that you can talk into in order to control your televisions. I don't know if you noticed, but on that previous slide was this toilet. And the toilet is there because this is also a connected device. So this is a product that is Alexa powered, which means that anytime you go into the washroom, you can have a chit chat with your Alexa powered toilet if you want. And there you go. And you may be saying to yourself, why do we need to talk to our toilets? That doesn't make a lot of sense. Well, again, let's take a little bit of a deeper dive because there's other technology that's part of this ecosystem. So Amazon has recently started selling glasses. These are what I would call dumb smart glasses. These are echo frames. They don't have a digital overlay, so there's no mixed reality or extended reality or augmented reality. There is, however, a voice activation in the temple, so way back here, that listens to you and can respond. So it's Alexa powered. Amazon also has a Ring that, again, allows you to interact and talk to a digital assistant. Here's where things start to get interesting because about a week ago, Amazon launched Halo. It's a fitness tracker, so it's a wristband that you would wear. But rather than simply tracking your steps, Halo does other things. It tracks your emotional state by listening to the tone of your voice all day long. So let's say that you're at work or you're in your research lab and you get really upset about something at around 9 o'clock in the morning. And a couple of hours later, your mood has subsided. Your wristband knows that because it's been tracking you. And it will track all the times during the day that you felt energized, a little depressed or low, a little stressed out. And this fitness tracker, this Halo, this Ring, is meant to track sort of holistically how you're doing. And what's interesting about this is that unlike other trackers, it doesn't just reward you with points when you've done good things. It also subtracts points, which is the first time that we've seen anything like this on the market. So if you're sedentary too long, if you've been too stressed out during the day, if you're not getting enough sleep, it will punish you by deducting points. So in the sort of critical infrastructure landscape, if we've got a whole bunch of smart devices, that means our households now are generating enormous amounts of data. Some of it's collected, some of it is more like a digital emission that doesn't really go anywhere. If we're wearing a wristband that's continuously listening, then that means there's a system that knows how we're feeling, how we're thinking, what our daily movements are. And if we're wearing some of these other devices, like glasses, a ring, and we're using a connected toilet, that means that at any given time, we'll know our temperature, we'll have a measurement of our oxygen, our pulse, our stress level. And anytime we go to the bathroom, we could have a urinalysis, check for kidney inflammation, high blood sugar, bacterial infection, things like that. Now, what's interesting is that these are the kinds of things that we associate with a hospital or a doctor's office, not our homes, and certainly not our offices. And yet, this is the transition that we seem to be headed into. So if we take all that synthetic media and we combine it now with this core infrastructure, what else can we learn? Well, Amazon, among other big tech companies, have been working on emotion recognition and detection for the purpose of synthesizing emotion and empathy. There is some research that's pretty compelling. Anytime that you talk to a smart speaker or a connected device, there's a baseline taken of your voice. And then obviously the system uses machine learning and deep learning to track for changes over time. So if normally you sound like this and, but today you're talking a little more, softly, slowly, or you're suddenly very, very hyper and you're moving around a lot, that's going to give an AI system some sense of what changes have happened to you. And those data can be correlated with your baseline over longer periods of time, plus location, plus, what's happening to your calendar, plus, right? All of these other things. And if we're in the process now of synthesizing emotion and empathy, that means that the synthetic characters that we start to interact with over time won't be so wooden. They'll be much more lifelike, much more realistic, and the interactions will be much more meaningful. And you'll start to see this over the next couple of years because Amazon, Apple, Google, Facebook, all of the companies, all of the big technology companies are starting to build emotion and empathy synthesis into their spoken interfaces. So that's kind of like obvious voice interfaces, but it turns out that technology can also infer somebody's emotions, even if we're not speaking. So we can do that now using wireless signals. This is a project from MIT that transmits radio frequency signal and analyzes it using reflections from a person's body to recognize their emotional state, whether they're happy or they're sad. And it uses an algorithm for extracting the heartbeat from a wireless signal with an accuracy that's comparable at this point to an on-body ECG monitor. So if we're able to understand and synthesize emotion, that also means that we can start replicating desire. So this is Cameron Jeffers. He's a YouTuber and had been using an indoor cycling program called Zwift. So imagine, if you're not familiar, sort of a stationary bicycle exercise program like Peloton, and combining that with a game. So this is where elite cyclists can compete. And the more that they ride, the more their avatars get strong, and then they get access to special bikes, which give them special powers. Okay, well, the thing is, people are now doing this for money. So this is an elite cyclist. He's admitted to robo-doping. He used a simulation program to ride continuously at an elevated power level so that he could get an upgrade to his virtual bicycle to give him an edge in the competition. So they found out he cheated. He was stripped of his title as the UK's first national cycling esports champion. And there was some big prize, a bunch of money, that obviously he had to give back. Okay, we're talking about a lot of different things. I don't know what the future of synthetic media and core level infrastructure looks like exactly, but there is enough data, there's enough research, enough evidence that we can start making connections and asking questions. Like, how does synthetic media inform your work going forward? How could synthetic media lead to more social innovation? What if somebody robo-dopes in your lab or on the job? What if they use a performance enhancing program? How would you know? What if they start subcontracting parts of their workout to an automated system? What if your company or your government agency or your research lab someday has synthetic employees? How do you monitor them? What are the ethical use cases for synths? And what happens if somebody synthesizes somebody that you work with or your CEO? That is not a crazy question. It's already happened. So in the UK, somebody synthesized the voice of a CEO and then had that voice call a manager in the organization and told the person, the manager, who didn't understand what was going on, to wire around $243,000 back out to the scammer. It's already happened. All right, so we're talking about synthetic voices, faces, narratives, people, core level infrastructure. And now I want to talk about synthetic biology. We are moving from applied physics to applied biology. And yes, we are in the middle of an AI arms race. I think it's okay to call it that. But there's also a biotechnology race on too. And this one gets very little attention. We are talking a lot about biology lately, obviously, because of the COVID-19 pandemic. But But the thing that is underlying all of this, and that you will start to see a lot of over the next 10 years, are big innovations in synthetic biology. It's a new field, relatively. It combines engineering, computer science, and biology. You can think of all of this as living, programmable technology. It's been possible to edit DNA code since the early 2010s. Scientists have been using a physical molecular scissor technique called CRISPR and splicing the DNA molecule back together in a sort of biological ransom letter, which is great. I mean, it's very high tech. It's a great achievement. But the problem is that researchers can't directly see the changes that are being made to the molecule that they're working on. And it's very laborious, right? Each move requires manipulations that have to be experimentally validated. And all of this sort of becomes very indirect, it's very labor intensive, time consuming. Synthetic biology synthesizes the manipulation process. DNA sequences are loaded into tools using a text editor, making edits the way that you would with a word processor. And then eventually something kind of like a 3D printer is used to print out the new material. In this decade, synthetic biology is going to allow us to read, edit, and write life, which means that pretty soon we will program living biological structures as though they were tiny computers. The very first genome cost around $3 billion to sequence. Today, that's less than $1,000. And in China, a company called BGI is working to bring that price down to $100. And if you imagine that, you could have your entire genome sequenced for less than the price of these Air Jordans, these ridiculous tennis shoes. Synthetic biology investment is going to top $25 billion by 2024. In the United States, biotech makes up about 4% of our GDP. It's one of the fastest growing sectors of the US economy, and obviously faster now because of COVID, and we're seeing the same all around the world. So when we talk about synthetic biology, it's not far out science fiction. Yes, we are talking about creating new types of living structures. What you see is called a xenobot. It's a living machine, and it's an entirely new kind of life form that never existed before. And it required a supercomputer, a virtual environment, evolutionary algorithms, some of the same things that underpin all the synthetic media I just showed you. There are lots of good use cases for this technology. Climate change threatens life as we know it, between floods and droughts and bad storms. You know, all of these things destabilize local infrastructure. They impact our economies. They overwhelm disaster response capabilities. Right now, on the west coast of the United States, you know, everything is on fire. And Australia suffered some of the worst fires in history just a few months ago. So one positive use case of synthetic biology is terraforming. So it would be faster to rebuild what's burned down if we can program and build and synthesize more material that can live there. And if we're going to do that, we could potentially engineer a new species of fire-resistant grass or tree. Right now, we are in the launch window for trips to Mars. So there's a lot happening between the Earth and space. But if we're really going to bring Earth life to Mars, we're going to have to terraform there too. It will need to be engineered. We'll need to accelerate the evolution of organisms that we can eat, probably even evolve us, Homo sapiens, so that our future generations have genetic traits required to survive off planet. Before we had COVID-19, there was another global pandemic, the African swine flu. It wiped out half the global supply of pigs, the majority of which were in China. This caused pork prices to rise. It led to unemployment. And China has been engineering, using synthetic biology to replace its herd, and not just replace them, but make future pigs less susceptible to cold weather. There are so many projects that are on the horizon. This one has to do with synthetic spores. Every now and then, there are disease outbreaks on farms in the United States, we had some issues with romaine lettuce and listeria. It can be very hard to trace back through the supply chain where the problem originated. So these scientists created synthetic spores that have little tiny barcodes on them, and they can spray that onto produce. And if at some point there's a problem, we would immediately be able to trace back where the lettuce came from because it's got a barcode. We would see it. At Harvard Medical School, there's research going on that is trying to look at aging as pathology rather than inevitability, right? As a pathology, meaning that aging could be treated. You could use genome sequencing and synthetic biology to take a snapshot of your cells when you're young, when you're 25, and then in the future synthesize cells that could grow into any part of your body, which means that you could at some point, you would still age, but not in a way that was sort of challenging. So again, we've got a lot of questions, right? How could we encrypt our genomes? And if we don't encrypt our genomes, is our body hackable? What if bad actors gained access to genetic data and start to use it for bad purposes? We talked about the swine flu. If we can solve the supply chain, that's great. But what about edits? Is it okay for one country to have right access to its livestock population and to tweak it, which would impact subsequent generations? Could synthetic biology lead to more plant-based meat at scale? That would make us less vulnerable, potentially, and keep the global supply chain more stable. Obviously, there are biology, health, and medical implications here. And then there are some thornier questions, like who should have right access to life? And does this potentially mean that conflict in the future will be economic and biological rather than militaristic? And perhaps the biggest question of all, which is, well, what does synthetic media have to do with synthetic biology and you? Everything. The technology underpinning synthetic media, artificial intelligence, broadly speaking, but also spatial and temporal computing, computer vision, deep learning, deep convolutional networks. All of these things also underpin synthetic biology. This decade, we are transitioning from siloed technologies, physics alone, biology alone, to interdependent systems, which is why the work that's being done at Attract is so important. There is fantastic research being done. This Emerging Life project is studying the underlying chemical structures to better understand genetic manipulation. It's a big component of synthetic biology, and it will help push the field forward. This project, also part of the consortium, is also part of the synthetic biology ecosystem, because at some point we will need to print at scale programmable things like bacteria. It's another core component. And this project as well, super important. Biological processes are dynamic and they take place on different spatial and temporal scales. So a computer framework which is what this is, that pushes fluorescent volumetric imaging will eventually become a standard tool for biological applications. In business school, and then I'm done, in business school, we talk about value networks. So all of this research is interesting, but at some point, it either has to lead to other basic research or it has to get out of the lab, right, and into the marketplace. So we talk about value networks. A value network is a system of investors, researchers, businesses, and service providers that all work together to create value. The best example of this was actually born at CERN, the internet. Basic research led to new fundamental R&D breakthroughs, which created new jobs, new systems, new services 50 years ago, right? 50 years ago, there was no such thing as the cloud or video conferencing. And look at the enormous value generated because of all of that research that originated at CERN. If you had gone back to investors in 1971 and said, hey, someday We're all going to be connected wirelessly. We're going to be wearing smart glasses. We're going to go to the bathroom on an Alexa-powered toilet. Nobody would have believed you, and no investor would have given you money. But that's where we are today. I am telling you that in 20 years, we may not go to a clinic or a lab or a hospital to take a test. We might be printing our medication at home. And the soap operas and the telenovela and the dramas that we watch on television, we will be watching in a different form using our own data from our own lives to tell us stories about ourselves. And you might say, this is all very interesting. It's very futuristic. It's high risk, too much volatility. We'll wait. That would be a mistake. A futurist wouldn't wait to see what the future looks like. We always look for opportunities to take incremental action. I don't know what the year 2030 will look like. The math doesn't work out. There are too many variables, but it doesn't mean you don't take action. So I've shown you a bunch of research. Whether you are a government agency or a think tank or a student or an investor or a researcher, your job right now is to look at the work that's being undertaken by Attract and think through next order impacts. Where are there tactical actions that we can take today? Because we have a lot of data and evidence. And how does that connect to what we think the systems level evolution will be like for this field into the future, when we don't have a lot of data and evidence and we do have uncertainty, but we have the opportunity to shape what that looks like. How can whatever it is that we are doing contribute to the ecosystem, to the value network that's being created? Because if you wait, you will find that you are too far behind to have an impact. Failing to plan is planning to fail. So I will leave you with this, which is a way to get started. This is a folder that has a ton of research. It's all open source, and it is yours to explore. Thank you.
It's always a pleasure to listen to you and all these provocative thoughts that you're sharing. We did receive some questions, and I know you have to leave us like in a bit less than 10 minutes. So I just maybe ask you one or two questions. So the first one that came across was, all these technologies, are they making us less or worse or better human beings? Is it something that you're studying as well?
Sure. So listen, there's always dual use. With every technology that gets invented, there is the original use case that it was intended for, and then there are the other use cases that people come up with. Everybody knows, I mean, you guys know better than anybody. Technology itself isn't bad. It's what we do with it. Now, I think in some cases, a lot of this technology is definitely it's causing damage potentially to humanity, but it doesn't have to be that way. From my perspective, if we can model risk right now, then we can mitigate that risk. And again, we can reduce some of the uncertainties about our future. But my concern is that there's just not enough people thinking through the longer term. And that's the real problem.
Mm-hmm. And also in terms of as human beings, what would be the parameters that you would put forward to evaluate if it's better or I mean, like also how do you react to technology? Because it's maybe not new, filter based. It's there are different elements to this. So how do you kind of put the two together, and from technology you find a dialogue also with the humans?
Right. I think the problem is that the researchers tend to just be in the lab researching. The investors kind of contribute money and then expect quick returns. And regulators just don't pay attention until somebody gets upset. This is not collaborative. I studied game theory. That was what I did in college. To me, this is like a three-sided prisoner's dilemma argument. So nobody wins. The best way, and then what happens is you have a market crash, or you've got volatility, or you have a lot of regulation. So none of those outcomes are good. The best path forward is collaboration, where everybody is incentivized to do the best possible thing. And typically that means economic incentives, you know, and norms and standards that are enforceable versus regulations. But Romain, you said the word dialogue, and I think that's the key here. Having a dialogue, a continual dialogue about what it all means, which just doesn't happen enough.
Okay, fair point. And building on this as well, there was a question which I think kind of linked to this one. How the scenario that you're putting forward of synthetic biology and synthetic media will be distributed worldwide. There's a high chance that, it will leave some people behind.
Right, and I totally agree, but it doesn't have to be that way. When I look at, for example, Africa, years ago, Africa was very far ahead of the rest of the world in mobile payments. And Africa, there are different projects around Africa that have started to implement blockchain. So I do worry that big parts of the world and huge populations will be left behind if we don't figure out a way to bring everybody together. And we didn't talk about bias and discrimination and some other issues related to all of this. But the good news is that this is a transition. We are in a transition period, which means that we can make a decision to bring everybody together to collaborate right now. If we wait, then we start to have problems.
Okay, so the urgency of a dialogue.
Absolutely, which I think is good. What you're doing is a good thing.
Yeah, exactly. I mean, we're preparing the ground for the future, definitely.
That's right.
And also, I mean, you couldn't join us this morning, but we also had policymakers, and it was clear that technology by itself, I mean, this is something that cannot happen because there is always an impact, and then you have to have this dialogue happening as well.
That's right.
Maybe last question. It was linked to, I guess this might happen to you a lot. Like, okay, what's next after the synthetic decade? Which is linked to also another question is, when you come across, I don't know, a new concept or a new technology, how do you actually realize that they are revolutionary?
Sure.
I mean, what's your process about it?
What's the process? So that's another whole thing for a different time. So our process is very, very rigorous. We have a methodology and lots of different frameworks that take a little bit of time to explain. However, part of what I put in that folder explains what the process is, because I know futurist sounds a little bit like a made-up job title. Foresight academically goes back 120 years. And just like there are quantitative analysts who work in investment firms, I'm a quantitative futurist that does foresight modeling. So anybody can do it. It's not speculation. But there is a process to determine what's a weak signal, what's a strong signal, what is a longitudinal trend, how to evaluate the trajectory of that trend, and then how to model what comes next and how to prioritize. So for anybody who is a systems or a process thinker with an engineering background, you would totally love this work.
Okay, I'm sure some colleagues will love diving into it very soon.
Yes.
Just after this session, actually. Great. Amy, thanks a lot for joining us. I know it has been also very early in the morning for you. I know you have some interviews set up just right after this session. So definitely thanks again. And the good thing is that at least when you draw a concept like synthetic decade, then you force people to at least think about it for a decade. So that's what at least I'm going to be doing. So thanks for sharing all this material and the folder that you mentioned, all these ideas and the combination of it. And let's dialogue again soon. Thanks again.